I'm gonna make two videos. So basically, my line is on, but I'm gonna try to end rock. This. Basically, just share my laugh string because I got like a one or sequence of his wife. It doesn't make any sense, literally. So literally, I need to do it properly because this is like my thing. Okay, look, I'm streaming right now. Basically, I'm cooking right now, but I want to show this one cooking later. Because once it just feels like this is honestly sustainable. But look, like basically, I'm watching a video on the last Therom format, but I'm trying to do it properly. Okay, so what is it? So this video is the last one, but I've got to state before I get started. Okay, you get the license. Basically, you get before we start the video. No, let me just try to go do it properly. It's recording. Let me just get the no. No, I don't care what it's from. No, I clear the source problem. Literally, this is like the hardest thing they think it is, but this is easier thing for me. So this is for martial arts Therom. So I really start my broadcasting, but I'm really recording here. But I got my pen and paper literally. But this is the last Therom. This is what I'm saying.
So relativistic speeds.
So this is the last. This is like my how I watch it. I got my notes. I got everything
ready. Or momentum equals mass times velocity.
Well, I'm doing quantum physics while I'm cooking. So this is like kind of stress, but it's not stressful because I already know it because it's my reality.
This isn't actually the whole story here. It's actually E equals gamma.
Let me just do for math class. We don't know what this is.
Gamma mass times velocity. So gamma here is the Lorentz factor, which is 1 over the square root of 1 minus the velocity squared over the speed of light squared. So at really low speeds, this is irrelevant, and we change our equations to E equals mc squared, or momentum equals mass times velocity. The Lorentz factor is also incredibly important when you want to figure out how much the length of something changes, or how time dilation works. So the length to an observer is equal to the length of the object divided by the Lorentz factor. And the time for the observer, stationary, is equal to the Lorentz factor times the time that the object is experiencing. So let's take a look at what happens at normal everyday speeds. So when our velocity is much, much less than the speed of light, this term, the velocity over the speed of light, is almost zero. So when you're dividing a small number by something on the order of 10 to the 8 meters per second, it becomes almost so close to zero that we just call it zero. And then what you're left with is 1 over the square root of 1 minus 0. So that's just going to be 1 over the square root of 1, or 1 over 1,
perfect.
or 1. And when you multiply anything by 1, it's just going to be itself. So that's how we end up with E equals mc squared, or momentum equals mass times velocity. Or length equals...
I don't know the full... What she's doing is just deriving the equation for Lois Foster. But basically, if you don't, my take on it is, it's two observers watching a state of relativity. Two red waves. You get two sides. People that relativity. If you put someone on the moon and someone who goes, it's just like the kind of time dilation. That's what the Lois Foster really is. A reflection of light. But they don't really via medium, and that's what all it is. But this is just like straight driving there for me. So let's see how she does it.
5 times c. So how much would this change our equations? So the Lorentz factor is going to end up being 1 over the square root of 1 minus 0.5 times c over c. This whole thing is squared. So our c's are just going to cancel out, and we're just squaring 0.5. Of course, you can put in the actual speed and the actual speed of light, but when you have some percentage or some fraction of c, you can just use that.
So this is just taking one of the constant speed of light, but speed of light is like a v squared, so it's the same thing, but it's backwards. So this is 5 is long.
Minus 0.5 squared, which essentially is going to give us 1 over 0.75 square root.
Oh,
That's 1.15. So even at half the speed of light, we're only changing by a factor of 1.15. So that means our energy is going to be 1.15 times what it normally would be at lower speeds. And same thing with momentum, 1.15
P is easy number.
times.
But this is E. This is not what. Oh, this what you call this E? I call this the lemon. This is the Hamiltonian, but it's flipped. This is not E. This is not
length works a little differently.
It's not easy.
It's divided by this factor. So our length is going to be 1 divided by 1.15 times the length of the moving frame. So 1 divided by 1.15 is just 0.87 times the normal length. So obviously this is going to change by a much bigger factor. If you're much closer to the speed of light, like 0.9, 0.95, and so on, it'll change much less if you're at 0.1 times the speed of light.
So this kind of annoying problem, but this is not what
how the Lorentz factor works and how it changes things.
Basically, people are getting it wrong. But
get ready, builders.
But I've got different models to do it. This is what I'm saying. This like
so in the last video, it's that x equals to ct.
So people are getting wrong. A lot of things wrong.
Now let's just assume, and we're sitting in the K system.
So x prime equals a of x minus b minus c. This is like the roots, but the roots are separated from the coefficient for the problem we get. Ct was the light and the time of the derivative. This x to prime equals ax minus bct, but it's just a quadratic equation via the determination of a prime number. So basically, this x prime equals ax. This is ax is like the variables in the a squared plus b x basically this quadratic equation is just quadratic equation, but it's just a Fermat formula because negative boy x basically only got so x negative boy couldn't side basically x equals y when the y equals to y x prime is y equals negative boy plus or minus square root couldn't side what's go right go apart, and that is couldn't side. That's 2 AC. Wait, 4. Let me write it down because I got it wrong. So this is I'm modeling right now. I know I'm modeling, but basically people are getting it wrong. I know how to solve this problem, but I don't want to do it mathematically because I'm cooking. But I didn't plan to do it. A negative y equals a negative boy couldn't decide what to go route to. A negative boy. I'm fucking up my equations literally because I'm rushing because I didn't plan to do it. Like but I'm gonna do it anyway. But because I'm doing it improperly, it's like a negative boy and b couldn't decide to go wrong for a b square. He's either not to go Mr. 4 or something. What's wrong with 2n? So basically, this is quadratic problem. This is what determines the symmetric equation. What is a parabola? A parabola. Like let's just we have two terms, x squared plus y squared. Equals r squared. If the radius is squared, you double the radius, you get a diameter. Diameter just define the problem in the pi framework. So just get the pi. Obviously, you get radius times 2 is the diameter, and that's just between 1 and 0, 1 and 1. So the radius is very important to get because I have the solution for it, and that's basically the vector model of it. So if you remember the conjugate pair rule, what I call get x squared minus y squared equals minus r squared, and this will be two sets of equations that you get. So basically you get if you don't understand, it's like literally it's what it is. But I'm making it clearer now because it's meant to be there. So you get r squared, which would be 0.5 squared, which would be 1. 1, but this is minus 5. 0.5, this would be minus 1. Which, when you square it, you are what? You're duplicate. So this is how you derive it. But you can have a kind of cool set of it. But you can get some that's in that state. This is called eigenvalues. Next to nothing. But I'm going to give you my take on this. I don't want to watch this video and waste your time, so I'm going to give you my take on it. So this way you get it. Because I got the screen opposite way. So here's where you get it. But this one you get it in time. So I'm going to say. I got this place right down with it. So what this means is you get the number 1 to minus 1. Literally, that's what you get. This is matrix 1 to 1 minus 1. But I define them by r squared, which is double. R squared is what? Radius squared. This is 0.5 times 2. 0.5 or times 2 or 0.5. But we get double, and that's the ratio of 1 minus 1 minus 1 based on the axis you're on. Note east south east and east and west. And basically this is how it works in the kind of polar system. This is why I love polar coordinates, because they do with spin. I never ever use Cartesian coordinates because it's just anti-practice. It's a bad because you're working with spin. Since we go that rotates on an axis. And that's why I don't want never use Cartesian coordinates, because unless I want some kind of state of a Cartesian system, I can use it. But basically, if I'm storing something statically as a static still state, it's active, but it just updates when it needs to. Which is still. So it just come for computation that needs to store, like the pi number pi. So I don't have to recompute the whole thing and the state I'm already in. So the quantum field span, my system updates without what is the quantum noise or fluctuation in the system. I love fluctuation, but wave propagates in oscillation. So this is like kind of not stupid to me. So this one is talking about x prime a squared minus b ct. This is just the kind of square root of the system, but it is the derivative of time. So the time is ct, which is constant time of speed. But this is the same thing as what the Rayleigh factor. So he's taking the derivative of all the. I just know that intuitively because the Rayleigh factor is just the if t equals 0, x prime equals a of t. This quadrant. Am I wrong? Let me just see. Basically, I didn't see him derive it, but I want to see what I derived.
Stop using ChatGPT and Canva like children's toys. Here's how to use them right.
Stop.
So,
but it's like a
square.
So it's like
the left-hand
basically
side
he's got some of this thing here, but this is s squared equals to s cubed. But this is like I don't even know what problem. This is the Lorentz transformation. So what is he trying to derive? A Lorentz transformation. This is not really the thing he's trying to do. He's going to do it, but doing poorly. So I'm gonna try to do the same thing, but better. So I don't want to look at this method because it's really difficult to make my mind because he just has a lot of mistakes I see here, and if I keep watching the video, I can make the same mistakes. So I'm gonna leave that. I love the diagrams. The diagrams are very good because he did them stuff. But I'm not gonna just follow. I'm gonna use the same analogy because I love teaching people too. But I'm trying to divide the Rayleigh structure as a transformation into this way. What's my trick? What's my joke? I am relentless. I mean, this is what education could be. It's not more in gaming. This is what education could be. Honestly, this is what education can be relentless. So let me try to do it now. I got some music to play. So you go to e to the power of I squared equals 0. Equals plus 1 equals 0. Plus 1 equals 0. But you don't need the plus 1. You never need plus 1. Because e to the power of I, e to Euler's identity, Euler's number to the power of I pi is equal to minus 1, which is equal to I. So that's what good. And you need minus 1. So you do need plus 1, you need minus 1. But they all share a negative state. Some kind of disjoint. Because it's negative, we share I'll get to what I'm saying, but this is what I'm trying to do. So we share a negative 1 state, which is negative 1, but literally they share that because it's basically just negative 1. This one just because it's like Euler's identity, so they have a negative 1 can do. So if you transform this on an axis, you get a negative growth. Think of this going oppositely on a system. Let me try to give you calculator. Give me calculator. So my calculator is this. So if I type in this number is minus 2.71828188284. But this is how many 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 9 numbers minus 2.7182 Wait, it's 272.718281. Oh, 281, not 282. So I'm saying because 82. 82. This kind of thing. 82. 82. No, sorry. So you get the decimal. This is minus 2 is this growth negative direction. So I'm saying because it's negative. So you have some actually e pi I. So this is growth or negative growth in other directions. This is why it matters. You just shows it works. The mouse works. So you can just get a negative equivalent of it. Pi, number pi. You get pi. Pi is a negative 3.141. I love pi, but to decimal precision. So 6153589. This is pi. I love pi. This is Euler's number, which is the standard growth. So we have Euler's. How you compute Euler's number? It's just you have something in the interval time. Let me compute. I'm gonna give you something. Something happens twice. For example, let's get 100% of something. 100% interest per. 10% interest. It's a growth function. So if a bank gives you what 50, I don't like that one actually, because that was too easy to use, but you know it's just the foundation of everything, so it's easy. So we get a bank for 1 early identity, so get 100% of something. So interest is 10% a month, every half month. So what you double interest every 4 weeks, that'll be 100%. No, 10%. No, you get 50% a month. 50%, and we get half every month. So every month, so in 4 months is 32. 7 times 4. That's 28 days. 28 days. So half of that is 12. So look at this is just how you grow, how you grow. So we become 50%. So if you have what £5, it becomes in 2 weeks, in 1 week, it becomes put £5 in a bank. In 1 week will become what? £5 in 1 week. £5 basically. I can't do this. £5 is like I'm very bad of me. I'm not even holding it properly for myself. Actually, I hate kind of this. So it's like I'm a bad hand to try to solve the problem. But it's what I'm saying. You get £5 per £5 1 week. £5 1 week is what? 5 times 1. So that'll be a quarter of the system. 5 times 1 quarter. That'll be 5 and 4, 20. 20. We have to add this 20. 5 times 4 is 20. All right, £20. So get £20 in 1 week. We get 4 weeks of it. So 5 times 20 is £5 plus 20 is what 25. So you see, not 25 at 25%. So this is how Euler's number is. So this 20 is just the Euler's identity. But they get that times 4. So every 4 weeks, they now get a second week. Now the second week this doubles. It doesn't quadruple. It just doubles. So you now get 20, 25. Now 25 is just a state the money you have now in the back. 25 times 5. Because the seed is still, so the 5 is preserved. Because you got a new state of 25. That's a double. 25 from 2 over 4 is 20. It's 100. 100 times 2 is 200. So you now get 200. Wait, am I right? No. 25 times 4 is 25. No, I'm not calculating. That's my 25 times 4 is what? 25 really. 25 times 4 is 100. 100 divided by 2. 100 divided by 2. 100 25 times 4. 25 times 4 is 100. Oh, basically, 25 times 4 is 100. I'm using a calculator. So 100 divided by 2 is 50. So you now get 50. So you get basically this 250. You just add them up and it'll be 100. So you get 100%. But this 100 is growth, full growth of the system of house. But yeah, it shows it works. So back to the example. So I would say this example is not wrong. It just needs more fine tuning. So this is trying to derive a log transformation. This log transformation is very ambiguous. It doesn't really align with the principle I'm really going with. But there's some kind of misalignment with the actual choice. But he doesn't know what it is at this time. But he's special relativity. So this is Dean Bean. What time? Dean Bean. So this is what I'm saying. So this is like my first work family. So what am I trying to do? So basically, why this problem matters to me, first of all, is I don't want to talk about the problem here, what matters to me, but I'm going to write down. So this is a Royal transformation. So I'm going to say why I need it, because I can't forget. If I read it right, I forget. So you get 4 axes of 4 axes, you get 4 polar coordinate systems. That's like 4 quadrants. So you have 4 quadrants. You get the left quadrant, which is what? The left one, which is what minus 80, plus 80. You get 4 quadrants, which is like the 4 axes, 90 degrees, minus 90 degrees. You get 1, 2, 3, 4, and you go anti-clockwise. Those go anti-clockwise. They are IV. Which is cool. So this is the top left quadrant is 0 to 90, up and down, and that will be basically secant and the dual system of our system. So that's what I'm saying. But the problem with the Rhodes factor is like I don't remember the Rhodes equation. Basically, the Rhodes factor is a crucial component in theoretically defined by gamma. Gamma function units. So saying. But it's like Look, I love this video. I'm gonna subscribe. I'm gonna sign in. I'm gonna sign in. Literally, I'm gonna sign in. So the reference is providing implication of energy conservation. Wow, with the with the as objects approach light speed, must account for include value. Oh, this is about energy. That's what matters. I do have my energy framework in mind, which is electrolysis in mind, but gamma essentially basically this is what I'm saying. You know, it's basically transformation. This is like a solvable problem on theory of relativity. Why would you guys just say so? But this is Fermat's last theorem, this Lorentz factor. I'm working the wrong framework. I'm looking with wrong thing. But this is a Lorentz transformation. This one I wanted to work on. But you know, I don't want to talk about formula routers, so get this one done because I want to do this for a long time. So the Lorentz factor is just this equation. This question is not scary. It's just like like I don't remember, but just you can see. But I don't really want to remember it. I haven't done it in a long time, so I just like I just think it's a symbol and a glyph. You know, I don't even want to look at it, but you know, it's so important when you want to write down. And that's the problem I have sometimes. So the derivative is divided by V is the length of and the C is going on vacuum. B is the distribution ratio and C is going proper time. From okay, basically this is all wrong. This is all like not wrong. It's I won't say it's wrong. I won't say it's wrong. I love it, but it's too linear. It's too linear. I just what I don't like about it. It's not it doesn't respect anything. I this is the problem. This is gamma factor. The gamma factor is the lowest term with the gamma factor. It reminds me. It's like when you say gamma, I'm thinking of gamma as in the gamma waves it propagates. Is that why they call it gamma factor? But I love it because it's just gives me more clarity because I don't think about the problem in another way. That's why I love it. Gamma term, gamma factor, Lorentz term. A dimensionless quantity, expression of how much measure depends on dimensionless. That means it has no volume. No, it has the volume, and that volume is noisy. That's what it is. Basically, you say dimensionless, it has the volume. But that volume is noisy. You can't really pull information out with tools. So basically, I got it right. I know I'm doing. So let me try to define it properly. How many times have I got? So this this is computation. So what is let's go 1, 2, 3, 4. Momentum. Something moving at a distance. This is the momentum of the law structure. Derived by stop it. For my last story. No, it's the wrong one. Applying the rapidity to hyperbolic angles time. But this is a rotational representation of the momentum rapidity. The rapidity function of the momentum is a change of the curve at a point in time. But this is not fully formed. It's like kind of disjoint. This is graph of revolution. So it's kind of linear. It doesn't make any sense why you didn't get like this, guys. Guys, let me just tell you how I do it. Y left and really, this is why I do sigma form. But the B bottom is beta. Beta waves, light beta waves. No. Basically, this beta waves. This is the version of 9. Basically, I'm using my relay system together. I don't want to fuck this up. Let me do more fun. So I know a problem here. Namdi, this is an easy problem for you. I know it's not stupid. It's not stupid, but I can solve it right now. I need to do it. Let me get some dinner. But this is my food here. This is something. Give me 1 second, guys. I'm trying to do it because I've got food here to eat. So I've got food right here. It's not hard to get it. I just have to relax it. This is what I have to do. Basically, I got my guys. This is take a picture. If I can't eat it, if I don't eat, I will not solve the problem. I will not solve it my way. I will not be actually solving the problem. And I don't make mistakes, and I don't want to make mistakes. And I want to make it all right. Yeah, all right. So I'll eat because you be too. If I want to eat my mask. So literally, it's because I love my life. I mean, I love it because it's good enough for me. It's not good enough. I don't want a simple life. I want a great life. I want the best life of my life. No, look at it. So this should be recorded. This I'm cooking, guys. Like literally, I still don't fucking care. I should be checking this on YouTube too. So I should go do that. This is not the way we're checking this. What I'm saying. So this Lorentz factor is solvable for me. I just know it. So this is why I just cooked. This like, well, I can't find it there. Basically, I can't find it there. I'm on the cool. It's all cooled down already, but it's live right. Right. But look at this one. I'm going to eat. It's got like a lot of juice on it, but it's not really I don't think it's good for me. Wow. Guys, this is like rice, but it's rice that's I just hooked up. Like, look at this. This is just no. Oh wow, man. Oh, it's so sweet. Sweet potato. Of course, it's sweet. It's good. It's good I made it. You know, if I didn't make it, I would have been suffering. Let's go with the problem. I got a few problems to tackle, but I'm gonna put that problem on the side. But the first problem I have, I read it down, so I got it written down, and I got it written down. I just brought myself in dinner. It should be fine, guys. It should be too bad because nothing bad happened tonight in this live cam. Sorry. I go up later. Okay, I just eat that. I'll go. Okay, but I make videos. So, what time you want me to go? Half an hour. Okay, fair long.
Yeah, you can stay half an hour.
Thank you. Because look, it costs me so. Thank you. It means so much to me. But it means so much to me because my family not here. My head spin. You don't know what it means to me because if in my house, I'll be down here everything. But you want to do. That's what it means to me. You care. I mean, you want to do. That's what I mean. You know what I'm saying? Because no one told me they care. They told me they care. They told me they care. You know what I'm saying? So me, I know everything because I know how I process information. If I don't know how to do something, why come here? That's smart. Look. I'm smart because I know what I do, how I do. I plan everything. That's what. Sorry, that's what we're meant to do. No matter if you grow up, don't go into the team. You get the family support. You get no. No matter if you're bad enough, we're not teaching that. You don't get it because you need it. Then just get how so that look. What I'm tired of here. I tell everyone, but why I'm really angry is do you respect me? If you respect me and I'm smart, why be here? They say, your job is not. I know it'll be a long time with you, but 6 months is too much for me. I'm tired of it. I just know how I do. If I don't get a plan, I took my plan. I go to plan.
Yeah.
If I don't get a plan, why tell you? But I don't just tell you my plan because my plan get house. If I don't get house service, why tell you my plan? Get house. If I go housing, these people are birds. I don't just tell them how it's not a service. It's not a service. I'm saying nobody can do it. No, that's how we work in Nigeria. Look, you don't know Nigeria. My dad don't teach me. My dad teach you what? How I know my dad? My dad go. My dad has a fire shop, fire extinguisher shop. He gave me fire, sell fire. So you teach me 1 week, 2 weeks, 1 week I learn. 2 weeks I run shop. You don't believe me, but I know how to sell this fire extinguisher shop. Because I know how to sell it. I know how to sell it because I know how I do in Nigeria. Because my father took me when I was 5 years old, 4 years old, 6 years old, and I was selling this kind of thing. That's how I know how to do. That's what you meant to do that for your child, everything. But your child know how to do in the shop. That's what we do in our country. Because that's what it's this man here, this Arabic man in his country, his son, teach his son. But he's similar to run shop, he has all his son. You don't need to be that old to run the shop, you know what I'm saying? That's what law is cheap in the UK. Because I run shop for my dad, I sell fire fish, I do everything my dad, and I still get money, I still run myself. Look, this country rubbish.
Did you finish the life?
Yes, I'm done. I only
Can I
want
have the life, please?
Yes. Okay.
If you don't mind.
Okay, fine. Okay.
Yeah.
Okay. This is song. But you really tell me so I just do. But I don't need it now. It's hard because you don't need support. But you get support at the wrong age. That's what I say. If you get support, if your son runs your business, you be doing so much work. No. And that's what my dad did when he was young. Now he don't do get himself fine. Just shop like this. His dad do this business. This is my dad. How you do now? You wait for me that place and wait for that person. That's where I go. That's where I go. That's where I go back. My dad has Then you do like that. Yeah, sure. That shop's still there. But that's a sharp that place, you know. That's the jazz dances. And I have it now. That's what I'm saying. I have things I want to do in my country. But if I take, look, I just give you example. That's what I tell you. You know, if I don't give example, it doesn't make sense. And I do like that, I do not be here. That's only know how I do, how I get, and that's why I say that it's problematic. So what was I? So literally, I've been eating. Yes, I've been eating. Just like I've got this on my lap here. And my salt is there. It's not really salty anymore. But I'm going to chicken here. So this is all delicious. This is so easy. This sauce is not really cooked. Okay. This is all good, huh? No. This is what came from. Look at this. There's no chicken here. It's not needed. No reason. I mean, I'm gonna try it. I'm gonna get some to steak, but every put it off. No, at least just put too much in it. But I'm gonna spend 30 minutes down here. I have a chance to do so. I feel I fuck it up. The fork is fine. So we're gonna because I'm gonna keep a steady heartbeat, like the sun, control my temperature. So I can solve the problem. The mass problem, the physics problem. Sorry, I did apply physics. I did apply physics. I did apply physics and physics. So actually, we need to solve it properly with my framework already invented. So it's meant to done properly. It's like I'm like a statistics on this from EDC. It's interesting. Interesting. Okay. It doesn't taste salty at all, is that? I mean, when I put soy, it tastes salty. I think I just did perfectly this time. I don't know. Okay, I tasted there. It's so salty. Okay. Now let me mix it properly because I know I'm tasting salt. I know I'm tasting the salt. I know. I know it's the salt first. That's how I normally do it. Because I like it salt. It's kind of like it's not been cooked, so I have to mix them. The salt has to be I don't put salt normally properly because it needs to be done properly. So the salt is not properly done. So when I put a little salt, I have to mix it, but I don't mix it immediately. I just have to get it sweet. So because of sweet tooth, and that's what I'm saying. The problem is I have too much of sweet tooth. But it's not sweet because I like sweet things. That's what means like sweet things. But this is just rice and pasta. Literally. I'm going to Japan. Japan. But I'm gonna go there properly. So this washing machine is under here. I mean, it's meant to be like this, honestly. I swear to God. Okay, let me just oh, this is Eunice. But this is not the frame from the hand. It's not stopping. Okay, let me just try to. I'll just stop. This is over 1 hour. I don't know. No, it's gonna be 45 minutes. 45 minutes would be 8 minutes left. So let me continue. So basically, this was where I was. No. So basically, this problem was this is the measure of gamma factor. I don't know what the gamma factor is. It's the measureless quantity. One dimension. Quantities of dimension one. Quantities quantity person defined in a manner it prevents the emission of the use of measurement. Typically expressed as ratio that aligns with our system. Continue to define the units. This is alcohol by volume. Volume is a volume problem. This one basically I'm gonna try to radian serves the angular measurement. Yes. 2 pi. 2 pi. Yes. 2 pi. Standard 1. 2 pi. Equal to 6. Basically, this one is saying. Okay. So let me have a go of this. So basically, history. Dimensional analysis. Quantities have dimensions. Yes. Dimension quantities are regular size. Oh my goodness. But what's the dimensionless quantity? Buckham's notation, Pinus theorem. The Buckham's theorem does depend on the space unit, but estimates of theories ratio, Boy's law. But this is very buoyancy. Buoyancy. Boy's law is the Boy's it's like a gas law. So basically, press temp. Oh, this same thing. Press it. Oh, basically, yes, the same problem here. This is the main problem I'm trying to address. So this same thing. This is where it all starts for me. Let's say Boy's law demonstration. Let's see what this is. This is Boyle's law demonstration.
In a demonstration of Boyle's law, we'll place a balloon in a vacuum bell jar. We'll apply a vacuum, which basically pumps out the air in the bell jar. The pressure outside the balloon will be greater than the pressure inside. The balloon expands to try and equalize the pressure. Volume and pressure are inversely related to each other. When we release the vacuum, the pressure increases and the volume decreases. As another demonstration of Boyle's law, we will put a marshmallow peep into our vacuum jar. The marshmallow contains air trapped in a mixture of gelatin and sugar. As we apply the vacuum, the pressure outside is lower than the pressure inside. The air in the peep will expand to try and equalize the pressure. When we release the vacuum, the pressure increases and the volume decreases. As another illustration of Boyle's law, we will put some shaving cream into our vacuum jar. The shaving cream contains...
Oh no, shaving cream. So pressure.
Illustration of Boyle's law. We will put some shaving cream.
Shaving cream. Oh, shaving cream, just like a descriptor.
Air trapped in a soap mixture. As we apply a vacuum, the pressure outside is lower than the pressure inside. The shaving cream will expand to try and equalize the pressure. As you decrease the pressure, the volume increases.
Okay. Okay. Okay, what the form of this? Gaussian. I don't hate this, guys. I just think it's different. Like statistical instruction. That's what it is. Power over velocity is the time. This is power over time. This is just like this making all the sense, man. Namdi, this is making a lot of sense now. Namdi, this is making too much sense. Okay, let's do it properly. Let's do it this way. So dimension, let's do some definitions. So we go for using pi frameworks. Okay, using pi to model this. So before I start doing this, I have to state some things. So we got which I'm trying to model this is 3 things. We got some 3 dimensions of accuracy. I'm gonna use my one to do it. I'm gonna put my model. So I'm gonna put my diagram, but I'm gonna put it in my pocket for now. But it's the same thing I got right now in my head already. So we good in my head. So we're done in my head. So I'm gonna put it in my pocket. Sorry, I don't want to lose it. Because I'm gonna put it in my pocket. So here we go. What I call a dimension of space and time, and that is a lepton. 0.5, no, 0.5 positive, 0.5 is a lepton, and we get half 0.5 as well, 0.25, and that's a muon, and the 0. Opposite end of it is 0. Measure of matter is what? A 2r. This I'm saying. This is the same thing as the axis. We get the as the axis. Because you are using this kind of model number. So this I'm saying. So the kind of problem with this is dimensional. It's only dimension. This is a Boy's theorem. So I'm going to give you the kind of what I'm thinking of it. I'm going to do this properly. So the lepton measures is a own plane, its own dimension. It's not just own dimension. So you think of the lepton. The lepton says obviously these have their own dimensions. What are leptons? So let's start with the definition stuff. So we're gonna have this kind of diagram. This is really an XYZ diagram, but you're gonna have definition to it. So we can keep it. So leptons are what? Basically left origins. You get lattice. So A lattice is like a quantum lattice or a quantum field. Not foam, a quantum field. So quantum field lattice. So get a sparse lattice, a sparse. Let's just make a tomographic lattice. Let me get a lattice. A lattice is what divided by what? A what? An eigenlattice. An eigen. This is called an eigenlattice. Eigen. So this measures nothing. Measurement of nothingness. Nothingness. Because when you're measuring pressure, there's a volume associated with that pressure, and that's what you're measuring. That's something has to go somewhere. Something has to get. Let's go to something has to get pressure or the volume. This you get something that a ratio of something like that brings to another system. It's like resolving kind of two systems in one, but they are working on two different kind of axes. For example, if electrons work on the plane on the XYZ on the x-axis and the basically working on the plane, the geometry of the plane, the lattice field. That is one field of them. So what are what is an anidode? No, wait, an anidode is positive. Anidode. It's anidode negative. Anidode it's just negative charge. It's an electron translation, but it's basically working in gravity, quantum system, basically gravity. But gravity we don't have graviton. We have something that's a field or a quantum field, which is the kind of equilibrium of the system. So it works basically. It's just everything is just statically charged. It's electron, definitely equilibrium structure. But basically you have the statically charged chemical step, which is graviton. Graviton is just there's no graviton is standard model of physics, and that's why I hate the kind of graviton, because you don't have gravity particle and you don't have gravity wave. You have electron, which is the gravity state of negatively charged electrons. At the equilibrium, nothingness, which of no sense, and that's your standard. So if you say 9.9 G, 9.8 G, that's gravity, you're measuring what electrons, and that's what you gotta think of. You don't ever say gravity is as a policy in this frame because that's what I'm saying. I'm gonna give you guys the thing I'm saying now. I think I'll just start a new video, like literally just annoying me. But it's wrong. Let me start a new video. So you don't say nothing, but let me just say like let me start this video. Alt S. This is my video stopped. So please, let's make a video of this. I'm gonna download this. This is a lepton. This graviton. Anti-graviton. No graviton. It's like point of physics. 101. So this is like in one I say, but it's gonna upload to two places literally. Because I'm trying to do it properly. Basically, I'm trying to listen to music and do it. Basically, I go like basically I'm uploading the video right now. Okay. It's like because I'm uploading this video right now, 101. Basically, the other 101 should be in the copy of the system that we. Basically, I got this like thing I'm doing here, but so you're trying to measure nothing, and the share let us be, but the share is plain. So this is the wrong model. I'm thinking wrong. This one is saying, oh no, this one no. Did I? No. Literally, this is copied, no? This is not copied. It's copied here, no? That's why I need basically I'm trying to get this like quantum physics 101 no copy. Basically I'm uploading this one like literally right now. This is the using like literally because I don't want to break this down like without timing. I'm gonna copy the I don't copy I don't I just I am the system. I'm the leader of quantum physics. I don't really care what you guys know what I'm doing. I hope levels are niggas recharge. I hope I'm speaking about leptons right because I don't remember the kind of leptons I'm talking about. Maybe it's a long time. You don't have to forget this now ever again.
Dinane, ele tinha que trabalhar para France, Italy, that's what train is about. The masses of
Oh, this one there's no growth involved in that decision. It's just pure noise. But I'm trying to make this a 1 hour stream. Let's see what DeepSeek thinks about this kind of thing I'm doing. It literally is annoying me. It doesn't.
কিন্তু উদ্যোগের থেকে যদি আছে 2.5 বছর শেষে গেলে তাহলে 2.5 বছর শেষে গেলে তাহলে আরো 2.5 বছর আরো 2.5 বছর শেষে আর পুরা 20 বছর লাগবে শেষ দিতে কিন্তু এর ভিতরে যদি আমি যেটা এগেইনস্ট কেস করছেন ধরো আমি দেশও দিয়ে আওয়ামী লীগের সরকার বাকি আছে ওখান থেকে ধর সাপোজ যে এখন এর ভিতরে যদি 10 বছর 15 বছর 20 বছর পরে আওয়ামী লীগ দেখলো ক্ষমতা দিয়ে তো তার এই পার্টির মানুষের তো আছে তখন তারা তোমার দল ক্ষমতা দিয়েছে এবং তোমার দেশ তোমার লাগে সেফ তুমি জানবে ও আইন এখন ও তাদের কিছু সব লিখবে ফিসে লাগছে তারা কোথায় গোয়েন করছে এবং ইগো করে দিব এসআইএমও ইগো 100% প্রতি মানুষের কোনো এটা নেই
Okay, ask me. Wait, what? 18 questions. I'm gonna paste Wikipedia article there. I was really looking at basically Wikipedia article. I don't really know. I don't really know like Wikipedia article is. What is that?
যদি আইন হয়ে যায় তাহলে যত টাকা কাম করবা খাইবা দেখবা ঘুরবা বাংলাদেশ যেতে পারবে না আর বাংলাদেশ যদি কোনোদিন দাম দর ক্ষমতা দেয় তাতে মায়ের দিকে লোকাল খাচ্ছে ও তোমার যদি মানে
So basically, I'm trying to literally just ask me. So basically, I can stop the stream and start again, but I don't wanna stop the stream. So let's just start again. So I'm gonna end the stream because I got the video uploaded, but I'm just gonna wait for the to just keep up to date. And that's what I'm gonna do. Basically, TikTok is open, actually it's open, but I'm trying to let me stop the stream and let me just know. If I stop the stream, I have to start again. Okay, I'm gonna start the stream. Once again, it's me. Sorry,